is thrown at 15 meters per second from a height of the cliff, from a cliff that is, let's say, 10 meters. What will be? Y initial equal to what? 10 meters. The question, find, before that, let me just make it simple. You throw from my hand, from the hand, so Y initial is 0. Find A, the total time, which is called hang time, right? Hang time. B, find the maximum height. C, find the time to reach the maximum height. D, find the velocity final. F, find the position or find the time at a meter. Okay, good. This is the problem. So that general problem, this is just to understand the process of free fall, how to describe the motion in free fall. Let's start with A. Find the time. How can we find the time? Let's look at the equation. If we want to find the time, do you want to find the time coming back to your hand? So what do you know about your hand? If the object go out of your hand, what is Y initial? And Y final? Still 0. So we know position, and we are looking for time. What is the equation that relates position and time? Of the three, what is the equation that relates position and time? The second equation. And that's what you have to look, right? Immediately. So information is not given explicitly. It's from your reading, from your analysis, reasoning. So, going out of your hand, Y initial is 0. It's not, they are not telling, but you can imply. And coming back to your hand, Y final is 0. Oh, I have position, and I have to look for time. Position, time dependence. Which equation? The second. So, normally, you rewrite the second equation because you want to visualize Y, YO, plus BOT, minus 1/2. I already put the negative. How much is Y final? Y initial? BO. T minus, for simplicity, to simplify calculation, I will use, instead of 9.8, I will use 10 in free response, not in multiple choice. But in free response, not in the homework online either. In free response, you can use 10 to simplify calculation. 10 over 2, how much? How can I solve this? I factor out. So 0, t, 15 minus 5t. Is that correct? So from here, 1t will be equal 0, which is the starting one, and 1t will be equal how much? 3 seconds. Good. A. B. I want to find the maximum height. What information you can imply about the maximum height? Not given explicitly, but you can imply. At the maximum height, what do we know? Velocity is 0. So, if we have velocity, 0, right? And we are looking for the maximum height, that is what? Maximum height in physics, what is that? It's not, my point is time, position, velocity, acceleration. It's the position, right? You are looking for position. So what is the relationship you have to establish? I have velocity and position. What is the velocity position? Velocity and position. The first, the second, or the third? The third, velocity and position. I don't have time. At the maximum height, I don't have the time. If I am asking you, find the maximum height, I am looking for position, right? I have the velocity initial, and I have the velocity final. What is the relationship between velocity and position? The third equation, right? So, probable is the third equation. Negative 2g y minus y0. Remember, the difference here, when I am putting in the negative, it doesn't have a line over. You get? I already substituted by negative g. This has a line over, is the vector. Two different things. So this already, I put the component. So what you know is that always will be negative 9.8, not double negative, just one. So what is B final? At the maximum height is 0. How much is B initial? Minus 2 times what? 20 times y minus 0. I am looking for the maximum height. Now y is not 0. Where y is 0? Where? At what point y is 0? Here, but not here. I am looking at the maximum height now. I stopped the problem there. So how much will be this? Y will be negative 225 divided by negative 20. 11 point, how much? 25? Y. We get Y. Y equal 11.25 meters. This is the max, 11.25 meters. This is the maximum height. C. I am looking for the time at the maximum height. Going up and down, how much time took? 3 seconds. If the path is symmetric and is the same gravity, up and down, how much is the time to get the maximum height? 1.5 seconds. Is that clear? So it takes the same time to go up than to go down. If 3 seconds is the whole time, half of the time will be 1.5 seconds. The path is symmetric. Coming back to the same point. So you can imply that, but you can calculate which equation, if I am looking for position, at this position find the time at the maximum height. Right? We want the time and the maximum height. We can use either the second equation, which is position versus time, or we know something about the maximum height, velocity. So can we use this equation? What is B final? At the maximum height?
0.
What is B initial? 15. We have the acceleration, negative 9.8 or negative 10, and we can get this. So if we use that equation, so we get V equal VO, negative G, T. This is 0, this is 15, minus 10T. How much I get for T? 1.5 seconds. Everybody can see that? Which was what we implied. You know, you don't have to do the calculation. This is a proof of that is 1.5. D. D. I want to be at y equals 0. If the path is symmetric, this is moving upward, and it's moving 15 meters per second. When it's coming downward, from 0 downward, how much will be the velocity? Negative 15. right? Is that clear? Because the path is symmetric. It comes out of here at 15, have to come back at negative 15. How can we prove that? Multiple equations. If we use this, let's use this one. B squared, that's what I want to find. How much is BO squared? 225 squared. Minus, let me just put here 15 squared, it doesn't matter. 15 squared minus 2 times 10 times 0 minus 0. Is that correct? Because coming back to your hand, it start here and come back here. How much will be this? What is the square root of 15 squared? No. Plus minus 15. Which one is the one you have to take? The negative 15. Right? The square root of this will be positive negative 15. And because I am asking for the velocity coming back to my hand, you know that will be the negative. That's one way. We can solve it also with this equation. How much is the time coming back? Coming back to your hand from the beginning to the end. 3 seconds. So if we put there in the same equation, D, this is D again, V equal to what? How much is VO? Gravity? Time 3, how much you get? Either way, you can prove that the velocity going downward will be negative 15. And finally, they want the time at 8 meter. Time at 8 meter, which equation? The second one, time at Y. Position dependent, time dependent. So we get Y T, I mean, what is Y final? 8 meter. How much is Y initial? How much is VO? Minus 1/2 T squared. 1/2 GT squared, how much will be? 5 T squared. Can you solve this equation? How can you solve this equation? Will be hard. Quadratic formula. Negative B plus minus the square root of B squared minus 4AC divided by 2A. How many answers you will get? 2. Why? Physically speaking. At 8 meters, where will be? Where will be? If this is 11.5 meters, from here to here it is 11.5 meters, where will be 8? So will be here, right? So why I have to get 2 times? 1 time going up and 1 time coming down. So can you see that? So you have to obtain 2 times. 1 will be less than what? 1 time will be less than what? 1.5, less than 1.5, 0.69. What will be the time going up after? Have to be greater than 1.5 and less than what? Less than 3, 2.3. This will be the 2 times. All right? With this, the class is over. Let's take a break.